So in this presentation, we're going to look a bit at cross multiplication. So first off, let's look at these two terms here. X over z plus y over z. And just a point to remark is that in both cases, the denominator, which is to say the bit underneath the fraction, here it is z and z, is the same in both cases. So you can add this expression here and this expression here simply by adding the numerators together and putting them over the common denominator. Suppose we have a different expression here. So that's just the first point. We'll just call that 1. The second point, let's call this expression a over b plus, let's say, x over y. And we want to get it into one single expression like we have done there in this particular instance. So what can we do here? What we could do here is we could multiply both terms above and below by the same value. So for example, in this case, what we're going to do, a over b, what we're going to do is multiply the numerator and the denominator, a and b, by the same value. So here a times y, b times y. It's a sort of educated guess coming because we're going to use this denominator here. So we have this over yb. On this side, what we're going to do is multiply both the numerator by b and the denominator by b. So again, what we have here is xb divided by yb. And again, in this particular instance now, that by, yb is essentially by. Just put the b's the other side if you want. We have this. So ay plus bx all over b times y. So that's how we could sort of simplify an expression like that. Let's try something a little bit more complicated and then go for something sort of exam standard. So b over 2 plus x over 3. So what we're going to do here is multiply b over 2 by 3. So we're going to have 3b over 2 times 3. And the other term, what we're going to do is multiply the numerator and the denominator by 2. So that's plus 2 times x over 2 times 3. And again, the denominator of this expression and the denominator of this expression is the same thing. So we have 3b plus 2x all over 6. Okay, so something a bit more high standard again. We're going to have 2 over x plus 1 plus 5 over x minus 1. Okay. So multiply above and below by the same thing for the first term. So you have 2 times x minus 1 all over x plus 1 times x minus 1. And the other expression there is 5x plus 1 divided by x minus 1 times x plus 1. And okay, just to sort of reinforce this point, it's essentially what we're doing here in both cases is multiplying by the denominator of the other term. Okay, so that works out to be, let's sort of go a little bit further with this. 2x minus 2 plus 5x plus 5 all over x plus 1 times x minus 1. That is equal to 2x plus 5x, that's equal to 7x, minus 2 plus 5, that is equal to 3. And x plus 1 times x minus 1, that's x squared. If you work it out, you get x squared minus 1. Okay. So what we're going to do now is try out something a little bit different. Okay. So what we're going to try out here is we're going to try and solve this expression here. So we have 4 over x squared minus 1. Okay. Remember that was x plus 1 times x minus 1. And we're going to let that equal to a over x plus 1 plus b over x minus 1. What we're going to do is actually the operation in reverse. Okay. So I'm going to multiply a by a and x plus 1 by x minus 1. So a times x minus 1 over x plus 1 x minus 1 plus b times x plus 1 over x minus 1 times x plus 1. Okay. So the denominator there, the common denominator is x squared minus 1, and we have ax minus a plus bx plus b. Okay. And now remember, this is equal to 4 over x squared minus 1. So necessarily what has happened is that the numerators are equal to each other. That's to say 4 must equal to this because the denominators are the same. Okay? So 4 is equal to ax minus a plus bx plus b. Okay, let's. What we're going to do first off is just re-express that. So we have 4 equals ax minus a plus bx plus b. What we're going to do is first off gather up all the terms that have x in them. So what we have is a plus b times x minus a plus b. I'm just going to go back here a second and just check I got that right. Yeah. So that's equal to 4. Now just recall, or let's just say for argument's sake, we can actually just write this as 0x plus 4. Okay? There's no sort of, we're not cheating or anything like that. We're not making any sort of, we're not making any logical contradictions. So what we could say is a plus b is equal to 0. Okay? Because we have a plus bx, and necessarily that must equal to 0. And also, what we could say is that we have minus a plus b, and that's equal to 4. Okay? So, minus a plus b is equal to 4. Okay. Now, so we have 2 equations and 2 unknowns. So the first equation there we had, that is a plus b. And the second equation, minus a plus b is equal to 2. If we rewrite the first equation, what we could say is a is equal to minus b. Okay? And if we use that in the second equation, or we could also say this, minus a is equal to b. Okay? If we use that in the second equation, minus a becomes b, plus b is equal to 4, 2b is equal to 4, b is equal to 2, therefore a is equal to minus 2. Okay, so let's sort of state the let's use those answers now. We found A and we found B. So what we could say here is that, let's just write it out again, 4x squared minus 1 is equal to A was minus 2 over x. Now I'll just check it so I get the answers in the right order. X plus 1. My plus 2 times 2 over x minus 1. Okay, so we've solved for A and B. Okay, so that is, I'll tell you what, we'll call it a day.